Good day everyone, welcome back to my channel. Today we are looking at trigonometry and we'll be specifically looking at surveying, our third installment on trigonometry. You will have often have seen land surveyors at work where roadworks are taking place. Surveyors work in groups of 3 and they use the Pythagoras theorem to measure distances which cannot easily be measured. For example, they measure distances across rivers, a deep valley, or a dam. Now, I'm going to point out a couple of illustrations on how this theorem actually works or how they apply this theorem of Pythagoras to solve real life situation. Now, assume, or rather suppose, we have a scenario whereby we have our right angle triangle okay. Now in this case we have 3 angles: angle A, angle B, and angle C. Now at each angle we have individuals who are actually working, or rather measuring this distances across the different parts of this dam. Okay, I'll indicate where the dam is in a moment, but before I indicate the dam, I would actually like to highlight or point out that we have those individuals who are working. So we have our surveyor who's looking across, or rather measuring the distance across from C to B, and then we have an individual who's basically observing okay, and then we have another individual at angle A. Okay, now we have a scenario here. So to highlight what the situation is actually all about, so it says here, a surveyor needs to find the width of the dam. So it's important now to indicate where the dam is. So here's the dam. This is now essentially where the dam is. In fact, let me amplify this just to bring it to reality. Okay, that's our dam. Now let's look at some of the information that is given here. It says the distance from A to B is 200 meters. So we know now that the distance from this point, I need to use a different color to be able to indicate this. The distance from A to B is 200 meters, so I'm gonna have to indicate 200 meters. Oh, sorry. I'm gonna have to use a pen for this. So we have distance from A to side B. We are actually told that it is 200 meters. So essentially this is what is happening. We are told that it is 200 meters. Okay. And then also we are also told that the distance from A to C is 100 meters. So this distance from A to C, now those from that point to that point there, is 100 meters. Let's go ahead and indicate that. So we have a distance of 100 meters here as well on the side. In fact, this is 100 meters. Just indicate this properly. We have 100 meters. Okay, so we just indicate distance of 100 meters from angle A to angle C. So we have 100 meters. There you go. Okay, now we are given this information. So we are also told, just to amplify this whole analogy, it says here the person at C makes use of the theodolite. That's a device that is used by surveyors. They're standing there at angle C to make sure that the angle ACB, in other words, angle ACB is equals to 90 degrees. What this means, it means that C, this angle here, is what he actually ensures that it is at an angle of 90 degrees. That's what it essentially means. Now, given the scope of this information, we can now start using our Pythagoras theorem. But before I start with this conception, just a couple of things that I like to highlight. We need to be able to identify the side opposite this angle, rather the 90 degree angle, which is now, this case, our hypotenuse. So we have C. We can identify 200 meters or C as 200 meters, which is our hypotenuse. In this case, is the longest side of this triangle or right angle triangle. And then we need to identify another composition in this case, the side opposite angle B. In this case, this side is actually 100 meters. So now all we need to do now in this case is essentially just to find side BC. In other words, from here to here, from this point to that other point across, basically. So let me indicate the side that we need to find, the side here. So technically we need to find the distance from B to C. In this case, we can call, because it's opposite angle A, so we can just simply say A. That's what we need to find. Now, in a nutshell, how we need to use the Pythagoras theorem is straightforward now. So technically, we're just going to need to write the original version of the Pythagoras theorem. So how it goes like this. we'll identify, say we're gonna say now, originally it goes like the c squared is equals to a squared plus b squared. Okay, c squared, in this case we know c squared. First, before we do the substitution of any value or of any kind of value, we need to actually first make a the subject of the formula, because that's what we need to find. So in this case we know that c, now side c, which is 200 meters, is the longest side, is our hypotenuse. It's very important to consider that. So in this case we actually gonna have to subtract b squared from c squared. In this case we substitute. That's how it should, our equation should look like. Now a is our subject of the formula in this case, so we need to now start substituting our values now in this case to compose the actual values, or rather find the actual values. In this case now we have 200 meters for c. In other words, we're just going to simply say 200 raised to the second power, and then substitute b squared. In this case b squared is just simply 100. 100 squared is equals to a squared. Now a squared is still the subject of the formula, so essentially now we have 200 square meters, or rather squared. So we know that 200 raised to the second power, we get 40,000. There you go. And then 100 raised to the second power, we get 10,000 is equals to a squared. Now essentially we are almost done, so we need to just simply subtract 100 squared from 200 squared. So 200 squared we get 40,000, and then 100 squared we actually get 10,000. So when you subtract that, you get 30,000 essentially. So that's 30,000 is equals to a squared. So what you need to do now is just to simply now square on both sides. Okay, and then once you square on both sides, the square will fall off. Sorry. And then once the square's fallen off, then we just simply now find the square root of 30,000. In this case is 173,205 meters. So essentially now what this means, it means that A is 173,205 meters. That's the distance. That's the distance of B to C. Okay, let's look at the last example that almost relates to the same example that we've just looked at now. Okay. Now this time we are given almost the same scenario like the first. Now essentially what you are given this time, we are given a plane. So it looks like this. See, this is what we are given. Okay, we have pediment here, so we have free face on the slope. This is the scenario. Okay. Okay, now essentially that's the scenario that is given. Now we are told that there are three individuals once again. So technically we have an individual standing on the side, on the other side, which is the side here, across, on top of the valley itself. Okay, then we have another individual to be standing on the other side. Okay, we have another individual standing corner there. Okay, now the scenario goes like this. So our scenario goes like this for this exercise. So we have an individual. Okay, at point E, we have another individual. At point D, this angle D. And then we have a surveyor. Who is holding his theodolite and is actually assessing this whole area. Now, what happens here is we need to actually be able to identify the different scenarios that are given here. In the diagram, the dotted line, rather not even a dotted line, but side DE represents the distance across the valley. Okay, in other words, from D to E, from D to E, it represents the distance across the valley. And then this distance is 147 meters. Okay. And then we look at the distance. Now it says here, the surveyor stands at F in such a way that the angle DEF, in other words DEF, I'm going to have to write that down, DEF is equals to a 90 degrees. Okay, in other words, this angle here, it's a 90 degrees. Okay. And then if she measures EF, remember EF, so we have DEF, we have F here, EF, She measures EFS 104 meters. Okay. Now we need to now find this side here. I'll call this E because opposite our angle E. So now to use Pythagoras once again, we essentially now need to actually be able to annotate to say that here, angle opposite angle D, we have side D. Opposite angle F, we have side F. So essentially how this actually applies, okay, we now need to devise our Pythagoras theorem, or rather use the Pythagoras theorem to be able to find the side of E. So essentially it will go like this: E squared is equals to D squared plus F squared. E squared is equals to D squared is 104 raised to the second power plus F squared. In this case, we have 147 raised to the second power. E squared is equals to 104. You can take your calculator. 104 raised to the second power is 10,816 plus, okay, plus, so 147 raised to the second power gives us 21,609. E squared is equals to, so when you add those two values together, we get the 2,425. So essentially when you square E squared and you square the answer on both sides, you remain with E. So the square root of the 2,425 is actually 180.07 when you round it off to 2 decimal places. So technically now what we have now, we have 180.07 meters. And then that brings us to the end of our presentation. So please like, share, and subscribe to my channel so that I can create more videos such as these. Thank you for watching. Bye.